And I'd like to say welcome. This is Agile in Action, and the topic today is refactoring the right way with Arlo Belshee and Marian Heather Willicke. So I'm going to introduce our hosts. I'd first like to say thank you to Applied Frameworks, my employer, for giving us this Zoom platform and supporting my work in taking this topic to the community here. Well, I'd say here in Charlotte, but it's not just in Charlotte. Let me introduce the hosts of our presenters. So I spent 6 years writing code. I was a software engineer at NASA and then at IBM. So I have my roots in being a maker, and I really appreciate technical agility and some of these topics that come up. And so I ran into Marian back when I lived in Western North Carolina, and she's an amazing instructional designer, educator, and visionary in terms of learning organizations. And Arlo's her partner, and they live in Asheville, North Carolina. And Deep Roots is their company. And Deep Roots unlocks an organization's ability to execute a technical strategy. And they do this through technical practices that integrate with everyday work to solve big issues like preparing code bases to make DevOps pipelines, bringing code to test, and what we're here today for, which is untangling legacy systems. So Arlo is our primary presenter today, and Marian really again, she's the director of learning at Deep Roots. She coaches trainers and professionals to create online learning experiences that deliver results. And she's written some amazing articles on instructional design that are available through her LinkedIn profile. And so without further ado, I will hand this over to both Arlo and Marian and say welcome, and really glad to have you here.
Thank you, Kurt, and thank you also Applied Frameworks for making this happen. As Kurt said, I'm Marian, and my passion is definitely making learning stick and to make it scale. But we're not here to talk about that. We're here to talk about straight up technical stuff, which is all Arlo. So what we did is split this into 3 chapters, and then at the end of each chapter, we're going to stop and look for questions. So if you have any questions about the content within a chapter, please post them in the chat, and then Kurt and I will back channel and make sure that those are all queued up for Arlo at the end of the chapter. And then of course, at the end of the whole session, we'll have a Q&A. So go ahead and take it away, Arlo.
Cool. So we always talk about successes, and I want to talk about a big failure. The reason I want to talk about failure here is because this is a story that many of us dream we could be a part of. And what I mean by that is, come on, clicky, clicky. All right, there we are. Okay. What I mean by that is this is a transformation, a technical transformation that was fully supported all the way around. The group got a new CTO. That CTO had actually been with the company for a decade, so knew everything that was going on, and was promoted from within. That person identified tech debt as the fundamental problem from the business perspective, got the CEO on board, and set the strategy for the company. They had 6 strategic pillars they were going to go after. 2 of those were directly related to tech debt. They were measured, they were driven from the top. There was a good, strong architecture in place. There was an architecture culture. There was a set of architects that were in every team, or every team's engineers would be elected to rotating roles as architects and come together and collaborate. And so there were all these organizational structures designed to help good ideas move throughout the code. Good culture of TDD. Everything is set up in the right way. The results, however, they were attempting to address technical debt. And after a couple of years, the result is they still had a monolith. They lost the CTO. They lost the senior VPs that agreed with them. They lost a number of other directors and VPs. The number one reason they had been going after tech debt was because they were having retention problems. The most senior staff had started to leave, and they were citing the horrible code and the difficult working conditions, basically, as their number one reason. And so they went after this problem to try and address that. And the result of going after this problem was that they lost 90% of their most senior staff. They also lost nearly all of the people that they had hired in to come help work on this, hired some DevOps folk and true natives to really help. They lost about 3 years of focused effort where they were doing efforts, but not as quickly on features. And they ended up with the new strategy of, we're going to be a feature factory. So it was pretty much a terrible outcome in a dream situation. I want to look at why. So the first assumption, of course, is either it must not really be the dream case, or there must be mismatched assumptions. So let's look at that. Chapter 1. In chapter 1, as we're getting started, the new CTO, he shows up, he has a mission. And this is a company that knows how to go after missions. So he identifies the mission as tech debt. We're going to go knock it down. And gets a whole bunch of belief around the developers. Everyone goes in, they're all aligned. Now, we might not be completely aligned on exactly what tech debt is. We might have some slightly different assumptions, but those assumptions mostly will work well together. Right? So as of this point, the CTO, he funded an organization to lead the movement. It's cross-functional. It works well with the architecture group. He hired a new senior vice president to run the tools group. He hired a bunch of ex-Amazonian people to be in the tools group and really bring DevOps thinking into the dev tool chain. And everyone gets really excited. He has the POs excited. He has everyone really focused on, we're going to address tech debt, and in addressing tech debt, we're going to solve a number of these business problems. There are still a number of people who are in name, but they don't quite know what it means, but that's okay, we're early on. However, so the organization's assumption, the focus here is, it's the automatic version of test quality in. So the focus here is, we're going to do early and frequent automated testing, and by doing that, the TDD style thing all will become good. So they hired a bunch of Amazon DevOps people, as I mentioned, and they released all of the people to go get the tests going. Okay. Now, the dev people and ops people and the new Amazon people who are doing sort of a DevOpsy role all had an assumption of building pipelines, basically. We believe that we want to come in and get our code to run in a pipe. Now, a lot of these people had lived the dream before. They'd worked at Amazon or some other company which had really good DevOps pipes going through, a lot of automated unit testing, frequent releases. They know what it's like. They want to recreate it here. Great. So they start thinking, let's just go set them up. The result, huge amount of money spent on running all of these pipelines, and they're almost always broken. So why? Well, the first part is a bit of reality. So it turns out that the assumptions of all the people were somewhat aligned with each other, but they were not aligned with the code. The code itself is a monolith. It's a bug-causing monolith in the way that all monoliths truly are. Many of the behaviors of the product happen as an emergent result. The thing is well designed, and that means that it has very strong entities, and it has different parts of the system that collaborate through those entities in different ways. As a result, many of the observed behaviors from a user perspective come from the emergent interactions of these. And as the system gets larger and larger, it means that more of the things that we come to depend on become attenuated throughout the system, where it's a little bit of this and a little bit of this interacting with a little bit of this in this way creates the experience that the user wants. And that results in spooky action at a distance, where I make a little change here and something way over there that I don't realize gets changed, both positively and, of course, bugs. The other thing is that being a monolith, it's really hard to build. It's really hard to build quickly, and it's really hard to test. You can't test any one part, both because of the spooky action problem, where anything you'd want to test is scattered everywhere, and because each piece is individually quite large. It does a whole bunch of different things. So the result is you can't easily get it in pipelines. you can, but they take forever to execute. And then since you're testing very large things, you make a small change and it breaks a whole bunch of tests. So at this point, one of the teams attempted to break free of the monolith. A couple of them did, but early on. And they had already learned a bunch of the incremental refactoring techniques that we'll be talking about later. They implemented those. They really started focusing on how could we break free, and that was all of their technical aspect of their work as they were going along. I mean, they were still doing features, but they did each feature from the perspective of how can we break this feature free so that we have our own component, that we're only working on our stuff and we're free of the monolith. The problem is, again, all of the behavior is emergent. And when you have a ton of emergent behavior, even as their code starts to break free, which they did after about 3 months of continual little refactorings along the way, they were able to get most of their code into a separate component so that most of their changes were in that component. But still, most of the behaviors that they were contributing to were the interaction of their component with other things that were still in the monolith. And as a result, they still had all those bugs, the spooky action bugs. That's not all. There's another dose of reality. And that is the habits. And of course, this habit here is one that we're all very familiar with. Should we do a bug? No, feature. And yes, that one happened a little. There was one SVP in particular who continued to prioritize features over bugs and certainly over bug prevention. As a result, he created an organization in which the only way to succeed, given that the message from the CTO was address technical debt and bugs, and the message from the SVP below him was do features first. The only way to succeed was to do your features and do all the bugs on the sly. And so people started sneaking, and of course that leads to all sorts of bad things, even if it comes from the best of intentions. At the end of the year, the team had then not produced the bug changes that the CTO wanted, but also not really produced the feature changes that the VP wanted. So the VP blames all of the directors and VPs below him, and those people all get turfed. And then a year later, more badness ensues. And by 2 to 3 years later, that senior VP is eventually removed, which was some loss to the company, but a huge loss to the organization, because that group under him basically didn't get to participate, never really moved, never really improved, and lost most of its staff well before we get to the end of our tale. But again, it's not just this problem. This is one habit that we have. We have the habit of thinking about features, but there are more. So another one is there are many missions. And this comes, at least in this case, it comes originally from the definition of leadership as used in HR. When you get to a certain level in the organization, you need to demonstrate leadership. That's part of your job, is to lead people. And that's true whether you are a nominal leader, like a manager or an exec, or a de facto leader, like a senior developer, right? You're intended to still set patterns and lead people. And the way that you demonstrate that is by setting a pattern, an idea, and getting others to execute along that idea. It seems great until you look at the organization and you see that 1/3 to 1/2 of the people are ones that are, for one reason or another, expected to demonstrate leadership. That means that you have between 1/3 and 1/2 as many different directions, ideas, and missions, minimum, as you do people in the company. There is no way that a company can succeed with 1,000 developers on 500 missions. Or in this case, 500 developers on 250 missions, right? And the result is that the mission here, the key one that we were really caring about from the CTO of eliminating the tech debt, gets lost in the noise. Because although that is the CTO's mission, you've got closer to you a dozen different leaders with a dozen different missions, many of which are smaller, that they have been working hard to figure out how to align their personal mission to the tech debt mission. But that doesn't mean they've been changing their personal mission. They've been reframing it. And it might or might not be the optimal way to achieve the tech debt mission. So that habit creates a number of problems. But there's more. So the next one is one that a lot of us fall prey to, and that is we see bugs as human error. Right? We see a bug, we see it as the finely crafted, accidental, but finely crafted creation of some developer somewhere. They were coding away and they typed in a bug and we have a problem. The thing is that that's not the way bugs ever work. The better way to think of it is that bugs exist before they exist. Like they exist in a potential. And then when a developer is coding, they're able to identify beforehand 99% of all the bugs that are trying to come into existence and prevent them. But one or two slip through. Right? And the more potential bugs there are out there, the more will slip through. Right? But because we still habitually think of bugs as created by humans, we look for human error. We look at, for example, when we're going to change code. One of the most common approaches to how I'm going to change code in a gnarly system, like this one was, and many of them are, is what we call the minimum invasive change. Right? You look for what's the smallest change that I can make to get my feature in. I've got this long method. I need to make one tweak here. I need to make one tweak there. And then this other method, I'll make this tweak over here, and I'll tie it into this object over there. And I'll just insert these 4 points, and then I'll put my little code off to the side. And in that way, I've changed the minimum amount of the pre-existing code. And this successfully minimizes the chance that I will introduce a bug right now. However, it maximizes the growth of the potential bug field because I have just made the code notably worse in order to decrease the chance of me writing a bug right now. And so I've created a whole bunch more future bugs for me and other people to accidentally miss. The other thing that happens from thinking of bugs as human error is we start learning to be careful. And being careful is never, ever, ever a good idea. But when we start analyzing these bugs or failures or whatever, we do the root causes, often we'll come to some place where a developer seems to have made a mistake. And if we think of bugs as caused by human error, we recognize that as a mistake. And we go, that person should have been careful. He should have known that when you're doing this funny stuff with this UI, it's a weird framework, and you've just got to really be careful with it. This database, when you're touching it, the locking is funny on it. And so if you're using these sort of statements with it, you got to be careful. Right? These networking aspects, this part is a little futzy. You got to be careful with it. Right? And we keep thinking of all those places of being careful. And we as developers get really, really good at being careful. We know a lot of these, and we really are careful in most of those places. But the result of being careful, again, is I minimize the chance of doing a bug now. And I leave the code in a place where one has to be careful. And over time, the code will get riskier and riskier to the level where my level of care starts causing bugs. And that becomes the limit of riskiness. So let's look at what went right. So in this first chapter, we already started to see a few things succeed. The first is that the company had used visualizations a lot, right? So we had a myth. The myth was that the broken builds came because the tooling was unstable and the systems that ran the tooling were unstable. The senior VP who'd been hired into the build tools group to fix that. They started looking at it. They really looked at the data, and they could identify that while there were some instabilities, the majority of flaws were actually because the code was bad. Some of them were bugs. A lot of them were flaky tests. And the reason the tests were flaky was because the code that they were testing was flaky. Right? So they needed to change this myth. And the way they did that was they started sending out a weekly email. And this weekly email had a bunch of sections. Each section was related to one cause of fundamental, consistent, systematic errors. And they had a team that owned each one of those. And that team had a title for their section of what the source of error was. They had a single visual, a single chart of some sort, and then 2 to 3 bullet points. And every week, every single one of these had this. And you could see each chart show, here's how big our problem is, here's what we're doing about it, and here's how it's changed over time. And then they could start highlighting how this isn't a problem, and this isn't a problem, and this isn't a problem, and this one is, but we've got it under control, and this one isn't, we've got it under control. And the ones that are left are the flaky code, right? So in that way, they were able to change an org's understanding of itself, that we're okay as the developers, we aren't really causing these problems, it's you guys over in the tools group that are, to really start reflecting that, yeah, we are the problem here. We need to do something about that. So another really good example here was they started shifting to team level choice with executive support. Now, they had had a refactoring team before that was attempting to go through and fix a bunch of stuff, and it was centrally funded. It was sent down from on high. The result of having a centralized refactoring team is that a lot of other people assumed, I need to make it good enough and then hand it off to these guys. They're the experts who will really get it right. And they got further and further behind. By having a dedicated refactoring team, they actually accelerated the poor design. So that group changed. They decided that instead what they needed to do was get everybody else on board and to understand what to do. So they identified 10 simple fixes. They were trying to reduce the build time. And to do that, there were 10 things that they wanted to reduce, 10 ways they wanted to reduce complexity and interactions so that things would build more quickly. For each one, they created a wiki page that had a recipe that was step-by-step. Type this, search for that, type this, search for that, do this other thing on the way through. So you didn't have to think. You could just follow that. It couldn't quite be scripted, but it felt like you were being scripted. Then they had a script that went through and discovered for those 10 recipes, every single place it appeared in the code. And they started asking people to do it. And no sale. Like, it was simple. Everyone agreed. Everyone wanted the build to be fast, but nobody did it. So then what they did was they took their script and they had it generate, instead of an output of every place, every single location that had that problem, they generated a task and put it into the planning tool. And they filled up the planning tool with like 15,000 tasks of fix this dependency. And as a result, then they handed those to the product owners, and they got a lukewarm response. It wasn't a no, because the product owners did believe in the need to fix technical debt. They understood where we were going, but it was still just too big and gnarly and detailed technical a problem. Right? So then the next thing that they did was they created a dashboard. And this gets, again, back to the visualizations, but they created a dashboard that made clear, allowed you to drill down to each of those locations. And you could drill down either by team or by section of code. And so you could see, how's my team doing on the code and stuff that we work with? And you could also see, I'm about to go into this portion of the code. Is there something I should pay attention to? Result, now everybody started picking them up. 10,000 fixes got done in the next year. And the problem became small. So we had some successes, but overall in chapter 1, we didn't really get much of anywhere. We were working on a bunch of different missions, and we made some progress on all those. Let's pause for questions.
Arlo, this is Kurt. Jason asked a question that I also had, which you said being careful is a bad thing. I think your phrasing was being careful is never a good idea, which struck me as counterintuitive, and Jason as well. Can you say a little bit more about that phrase?
Yeah. Yeah, so what I mean is, if you are careful, then the systematic result of that is that the world around you will get riskier until your level of care is necessary. If you are slapdash, but you need to make it safe, you need to ensure you have a good result, then the only way you can be slapdash is by changing the world around you so that it's less risky. So if I'm specifically, I'm in some code somewhere else, I'm making some change, I know that editing this method is really complex. It's got weird threading concerns on top of phase synchrony, on top of, it's all this nasty stuff all tied together with the database. If I sit there and I approach it as, wow, this is a dangerous piece of code, I need to be careful, I will deeply understand it. I will think it through. I will trace it all out, and I will make my very careful change. My very careful change will have to be fairly minimal. and its result will be to add a little bit of complexity to the system and maybe a bug, right? And those complexities will add up over time until you can't help but make a bug. Whereas if instead I say, I'm not going to be this careful, I'm not willing to be as careful as this code requires, my only chance for success is to reduce the level of care required. And so I have to figure out how am I going to separate the threading concern from the database concern from the other sorts of things here and make it so this is easy code. And then once it's easy code, I'll just change it.
Gotcha. Thanks, Arlo. We had, I know we're just starting chapter 2, and we have about 20 minutes left in the presentation. Michael did have a question. He was curious about what an example of a visualization of big problems looked like. Now that may be something that you can offer or not, but just kind of keep it in the back of your head as a question.
Yeah, they vary wildly. So in the case of the one that I was talking about there, where he'd identified the dependency structure, there were 2 visualizations. One was just the big ball of yarn of what files depend on what all the way through. And you just sort of zoom out and you look at how messy is this diagram, right? And over time, it gets less and less messier. And you're not able to see details, but you can just tell visually you're sort of making some progress. But one of the main visualizations that was used was just it's basically a histogram where it looked at sections of the code by big chunks and then how many dependencies that we wanted to eliminate there were in there. And you could click down and zoom in, and you zoom in and you zoom in until you could piece down to exactly what you wanted to look at. And you could look at that chart by org chart or by code structure. And when you get down to the very bottom, it has, this line of code is a type 3 dependency. Here's the link to the wiki that says how to fix it. Okay. Shall we?
Great. Let's keep moving, Arlo. Thanks.
Okay. So we had just started with mission, and we're all going to go for it. That didn't work. The obvious answer was we need a plan. We need not just a mission, but we need some organization here. Let's centralize. Let's plan this thing. We were failing. Now, when I say failing, we still had quarterly releases-ish. None of them were on time, but none of them were too late. But there were still bugs. There was still churn. There were still broken builds. Things hadn't really changed that much, even though time had passed and money and effort had been spent. So we're going to make a plan. We're going to focus it down. So here's our plan. And a couple of things are happening. One is at the sort of organizational and structured effort, and another is there's team-directed, just individual stuff going on. Some of the individual stuff is planned and some of it is invisible. And of the planned stuff, some of it aligns to the larger plan and some of it doesn't, which is the normal case. So what happens here? So first of all, we've got a bunch of good architect-driven strategic refactoring approaches. I mentioned briefly that we had a good architecture group. Every team knows which pieces of the architecture they care about. It's been broken into like 15 different areas of concern. And as a team, I know I care about, say, the UI and API and the asynchronicity. And that's what I care about. And so as a team, I elect a couple of my people on a rotating basis to go to those 3 groups. And I'm now interacting with those parts that I care about. And each one of those groups sends one person to the general architecture board. All of those are rotating positions. All staff are among those. It means everyone who's in an architecture role, their primary job is coding every day, and they're coding in a portion of the code that strongly interacts with the piece that they care about. And every team is directly tied to an architecture group, right? So this group knows what the problems are. They're really intimate with it. And when they figure out a solution, when they decide among the 12 of them what solution to do, well, the 12 teams that would go execute the solution are the 12 people who are in the room, right? So they just go execute it, right? So they create a really good set of plans for how they're going to address the problem. They drive through, for example, eliminating God classes and a number of these sorts of things, these redesigns. And they run into scheduling dependency hell. The problem is, again, the code is a monolith. It's that same problem. To fix any one problem, you have to fix all these other problems. For me to fix my problem, you have to fix yours in your code, and then he has to fix his in his code. And then there's other section of code here that's not really owned by anybody or is owned by 3 people, and it has to get a change there. And mine does align to the feature what I'm doing right now, but yours aligns to the feature you're doing 3 weeks from now, and his aligns to the feature he just did, and if only he'd known about it, right? And all these dependencies get in the way of doing anything. So then the next part is there's some centrally funded initiatives. So one of these, for example, was a big effort to clean up the integration tests. We had a bunch of long span tests. They're integrating several things. They're not like the whole system, but several things together in sort of a semi workflow of a human through one part of a real workflow, right? And these things fail. They're flaky, or at least a bunch of them are. And so the effort is to identify which ones really are flaky and why, and then break them into 3 camps. The stable ones, go ahead and keep running them. The flaky ones that we think we can fix, go ahead and fix. And the flaky ones that we can't fix, delete them and create stories for appropriate teams to introduce testing that isn't flaky. This really tries to go after all of these. And what we find in all of these centrally funded initiatives is they fall into 1 of 2 camps. Either they're peripheral, they are addressing a problem that's sort of on the side, or they quickly get overwhelmed. They just can't keep up with the rate of change of the organization, because you've got 500 devs. If you fund a team of 10 people to try and go fix a problem, they get outrun. So we had another example as we started getting further down, so a little more team driven from the architecture group, but a little more team. And that was code stewardship. Now the group correctly identified we didn't want code ownership. This code was it was too intertwined. And what I mean is the design and architecture were very, very good, but that meant that any business thing that I wanted to do, I had to make changes in several places, and other people would be changing some of those places too. Right? So it was very well componentized. It wasn't, it was then orthogonal to the business. And the result was that we wanted to do code stewardship, where we would identify for each section of code, who is a steward who's going to look at that code, intimately know it, and provide deep technical guidance. So when new people come into that code and are doing a flyby change, they can identify, do these kind of design changes, don't do those kind of design changes. Right? That code stewardship took years to organize, had fairly inconsistent results. Because again, it ran into this problem of coordinating among all of the groups where everyone is on a different short mission. Right. So we did see some benefits. We saw several more teams refactoring to break out of the monolith. And we started seeing safeguarding, particularly in one organization. But safeguarding is where they would start to use their bugs to identify what are the sources of their bugs and prevent future bugs. We'll talk a little bit about that in a moment. So overall, a lot of the centrally funded things and centrally planned things didn't really bear fruit. And the individually driven ones were very mixed. Some successes, some failures. But none of them could scale. Things that went right. Yeah.
Before you jump into what went right, we know we have visualization still on there as something that went right. Chi asked a question of if you know of any tool that can read the existing codes and create the dependencies.
There are some. So for this, it was looking at C++ header files. So they just wrote a quick and dirty parser in Python that looked for include tags because that's all they needed. But there are smarter tools, Sonar, for example, and others that can start analyzing languages that are where it's less about physical dependency. Okay, so some things that went right, and thank you for the interrupt there. Things that went right. We still had visualizations, team level choices. In fact, the visualizations had grown. We now had, for example, a visualization where we were analyzing source control. And by looking at source control, we could look at dev behavior. We could look at things like how frequently do people check in? How big is each commit? When they commit, how risky is it? Are they making a lot of changes while they're adding new code, or are they making refactoring style changes separate from that in code? How do they approach testing? We could start analyzing these things with our script and giving points to developers for awesome things they did. And there were visualizations and charts that showed the frequency of commit of developers and so on. And we could start tracking behaviors. So we also were starting to see safeguarding, as I mentioned before. So safeguarding is where a team will, once a week or so, they'll look at a couple of the bugs that they had, one or two of the really significant bugs that they want to go address, and they'll do a very quick root cause analysis, identify a few things that could have reduced the probability of having the bug, reduced the probability of missing the bug, and or reduce the impact of the bug or the cost to fix it. Right? And they'll look at all three of those elements. Right? And then once they have identified those, they've identified the hazards, they'll think of some partial fixes, which they'll put directly into the current sprint. They'll implement those partial fixes and they'll demo it. So we had one director who really supported this practice and gave space for demoing risk reductions, right? And gave mentoring to the teams of here's how you demo a reduction in risk. They really got those teams to agree because POs were already aligned to this whole reduced technical debt. They could fairly quickly get alignment that reducing the risk of bugs is one of the best ways to get everyone's needs met at the same time. And so they started, they got lots of good alignment among the POs and the teams, and they could schedule those things and get them done and get them into the demo. There was a good uniform prescriptive structure. Here's how a safeguarding meeting looks like. Here's what you do. And so people could just adopt it quickly. And they ended up having Scrum Masters teaching Scrum Masters and spreading it around the organization. It was very successful underneath that one director. It never spread to any other director because no one else gave both the space and the mentoring in how do you demo risk reduction. And risk reduction is something that we don't already know how to demo or really even how to think about. But it was very effective. It was a thing that went really well around that one team. We also saw some incremental refactoring showing up. There were 6 or 8 teams that had worked together to really learn how to do really tiny changes in refactoring in a very safe way, kind of the stuff that we actually teach. And those teams saw bugs really drop and stories really improve, good results for them. Unfortunately, the activity of refactoring is invisible to the people who are making the plan. And we're talking about an organization that has switched to centralized planning. So refactoring in this way was indistinguishable from what other people talked about refactoring, even though it gave different results. And therefore, it couldn't really get incorporated into the plan. And so the plan didn't have, do this kind of refactoring instead of that kind. And as a result, it stalled out. It didn't spread around the organization. Right? So those 6 or 8 teams got really good results, but no one else picked up on it. Which leads to chapter 3. Everyone's doing it wrong. So before we go there, any other questions?
No questions have been posted.
Awesome. So chapter 3, everyone's doing it wrong. Okay, we still saw that teams were often going in their own directions. Clearly the problem is this autonomy thing. We're going to high planning, no autonomy. The executives were in charge of the prior thing were fired. They did not get the results they had promised, and so they're out. There was a new set of Agile people brought in from a different company who had had a successful Agile transformation from the top down. Thou shalt do it our way, and we will call it Agile. It was extremely plan-driven. It was exactly all the things which the Agile people decry as terrible. As a result, 90% of the top talent leaves. Almost all of the people who had been in a DevOps culture before walk out the door within about 6 months. Almost all the people who had been with the company since its founding or for the last decade or so walk out the door. The senior staff walk out the door. The only people who remain are those who are fundamentally process compliant. They're willing to do whatever they're told. Work becomes rubber stamped, innovation goes to nil. Right. And the company today has a few frustrated people who are pretty good and a large number of people who will do whatever they're told and get their paycheck signed. And it's not that they're bad people. I don't want to say that. It's that the environment has made it that so that that is the only approach that survives. Even a number of these people in other environments have been fairly innovative, but within that organization, they've learned you've just got to do what you're told.
And Arlo, I'm curious about a couple things. This is Kurt. Is this company succeeding commercially? Is their market performance suffering as a result of this culture, or is their market performance level? Is it level and steady or improving?
So this company had already achieved market dominance.
Okay.
And so it will take 1 to 2 decades for a loss in innovation to show up in a loss in business. They are no longer able to attain the next market change. And so they are vulnerable to competitors, but it will take a little while before a competitor shows up to really knock them out. Right. They no longer have the really rapid growth, and their expansions are limited. They can't pivot to new businesses.
Mm. Gotcha. When the CTO came on, I don't want to dominate the questions, but this is a really fascinating case study to me. When the CTO came on and sort of declared this mandate or this vision, we will overcome technical debt. Did that CTO have business buy-in? Did he
Yes.
have partnership on the business side at the outset?
Yes, he did.
Okay.
Complete partnership. The head of sales and marketing was totally on board. The CEO was totally on board. The CEO had been in tech companies for quite some time, knew how much tech debt mattered. They were able to have the conversations of the true business impacts of those. And so those 2 pillars that I said were strongly tech debt related, the measures of success on those were actually business measures.
Gotcha.
Yeah.
Okay.
And yeah, the whole time, the product owner organization, everyone was aligned on it. Yeah. That's why it's an interesting case study, because it's one of those of, wait a minute, everything we say we need, this team had. Why didn't it work? So let's look into that.
Great, let's do it.
Epilogue. You don't have to be that story, but the question is, how can we avoid that? We said this team had everything we need. So the problem here is a fine example of success leads to failure. Each quarter, this group had like 100 teams. It's a little over that, but like 100 individual teams. And each quarter, there were something like 50 heroic efforts where a team made a fundamental change and improvement. And they, as a result of that change, they would reduce the bugs that team created by 50%. And the bugs created by 2 additional teams by another 25%. That had a fantastic effect, right? So all of these successes, in fact, most of the stories that I was talking about were successes. Right? They were all over the place. The problem is, at the same time, in that same quarter, 6,000 stories get implemented. And erosion beats heroic success. The normal way you do work either makes things ever so slightly worse or ever so slightly better. Let's look at the math. So in this example, they did 6,000 stories. If you do those heroic development fixes and each one reduces the entire total company's bugs by 1%, by reducing yours by 50% and some other people's by a chunk, you've got 50 of those happening in the quarter. You've got 6,000 stories. And each of those stories makes things 1/100% worse. Creates 1/100% more bugs. Right? That means that 1 in 100 of the bugs that you could create in the future, you create 1 more. Right? Excuse me, for your team, and that you have no impact on the rest of the organization. And that will make the total 1/100% worse. The result of those 50 heroic successes is the next quarter, the company produces 1.1 times as many bugs. And you can compute this as many quarters as you would like. Okay. That's terrible. If in those 6,000 stories, you still do all the heroic fixes, but each makes it only 1/1000% worse, you actually will get an improvement. Right? If you only increase the bugs by 1 in 1,000 instead of 1 in 100 for your team. Now, I don't know about you, but I have no way to tell in a story whether the change that I made is going to increase it by 1/100th% or 1/1000th% of future bugs, right? There's no real way to detect that. And that's the difference between success and failure. An interesting thing is, what if each thing makes it better? I can't tell when I make code a little worse versus a little worse, but I can tell the difference between making code a little worse and making code a little better by slightly decreasing the chance of bug as a part of my story. If I do that, if with every story, I only make it 1/1000th% better, that means I make no impact on the bugs created by other teams. And in this story, I decrease out of the 1,000 bugs that I would next create, I prevent one of them. If we do that on every story, then at the end of the quarter, we're creating half as many bugs. And you can do that quarter after quarter after quarter. Okay. That's the easy way to do it. And this is why we created Deep Roots. So the problem is we focus on the wrong thing. Like this company, it focused on the heroic fixes. It focused on all of those successes. And as an inspiring leader, that's what we have to focus on, because we believe from that perspective that leadership is about inspiring people. And the way you inspire people, the way you change minds, is you tell stories like this one, but you show successes, you show failures, you give these paths, and people choose what to follow. And that's true. That is the most effective way to change minds. The problem is here we're trying to change results. And results come from systems. And you can't change a system by making heroic fixes. You change a system by changing the normal everyday. We need to shift our focus from heroics to the everyman. What is the normal, boring thing that happens when no one's looking? And if you change that from being a slight erosion to a slight improvement, then the heroics become unnecessary. This is why we created Deep Roots. Deep Roots focuses on how do you make ongoing story development make the world slightly better.
Arlo, just to back up a little bit on the cultural level, Agile New England had a question of whether it's fair to say that a key to failure is people did not appreciate the severity of the problem caused by the code being monolithic.
Not in this case. People really appreciated it. People had identified that the direction the business needed to go, this was one of those cases where the business needed to get to the cloud. They needed to get there reasonably quickly, where by which I mean like 5 to 10 years, but not 10 to 15. And the number one obstacle to that was the monolithic nature. It just would not run in the right way. So we needed to break it up. People had also identified that somewhere around 45% or so of all the bugs were due to God classes and a few other design flaws, the monolith. And that accounted for a tremendous amount of churn. We could identify what percentage of our monthly churn was caused by these couple of design flaws. And everybody communicated that, from the CTO to the CEO. The CTO communicated, it was his number one talking point at every single all hands for a year and a half. It was in all of his one-on-ones with his directors. The directors had it in their annual requirement, or whatever, HR goals. Like it was there. People recognized the severity.
So it just boils back down to the code and our everyday habits. In this particular situation, it sounds like.
It really does. It's that the ongoing everyday is invisible.
Can you go ahead and go to the next slide?
Yeah.
This is something that we really work on, is to move from that hero to the everyday. And so I did want, before Craig, I see you have a question, and then others, I encourage you to go ahead and post your questions and we will get to those. But before, I wanted to close out with knowing that there's a few ways to start acting now. If you're recognizing the telltale signs that you might want to act, then go to the bit.ly contact Deep Roots, and you can do two things. You can look at the options there. You can start an educational venue within your company. You can figure out where you are, or you can work with us on just getting started with our tier 1. Whichever one of those, or if you just want to request recording and the slides, go to that bit.ly and we will respond as soon as possible.
And Marion, do we get some baby time in the consult as well?
I was trying to hide him.
You can't hide him. That's
He's
life right there.
determined. He's like, Mama, you're not including me.
That's right.
So yeah, so I encourage you to go to that bit.ly. Otherwise, Kurt, can you go ahead and facilitate the questions as they come in?
Yeah, sure can. Craig had an interesting question here, and thank you, Marion, for giving us some. And by the way, I'm going to send out an email, a follow-up email, laying out some ways to contact Arlo and Marion and kind of take next steps, and just either in terms of getting information. We'll also include the PDF of this this presentation, as well as a link to the recording. So Craig Cook said, "Are you suggesting that hiring 10x developers is not a good thing?"
Yeah. So my experience is that there are not really 10x developers. There are 10x systems, and that some people in some systems will have a 10x effect, but the same people in different systems won't. So for example, way back when my dad was a software manager, he had one person who never, ever met his deadlines. He had progressively narrowed the scope of work down to the point where the guy had one task to do in an entire quarter, and he still missed it. Right? And I'm like, what the heck is going on? And so he decided, like, he tried to work with the guy and mentor him and tried to get him to get some freaking code written and never really could. And so it finally had gotten to the point where he'd written it up a couple of times and it's getting time to fire him. And so fortunately, he went around and he talked with the team. And he talked with the team and he says, yeah, and every single developer that he talked to, they said, oh, no, you can't lose him. I only met my deadline this month because that guy came and helped me. And that guy came and helped me. And that guy came and helped me. And so they discovered that the right way to use this guy, he was the most important contributor on the team. And the way to use him was assign him no work. And then he will spend his entire day standing up and looking around for who's got a problem and helping them figure it out. Right? And that's the sort of a 10x developer. His team was 10x as a result of him being on it. But you would never hire him by looking for a 10x developer. Right? You can't really look for, if you look for the heroics, if you look for those hot points, what you're going to find is the person who stays up late at night to fix the bug that they caused. Right? There's another guy that my dad also hired, he was like 4 years in to working with this guy, and at one of the one-on-ones, he said, I was just looking through your history. And I wanted to pull up some stuff, and I was pulling up some stats, and I looked in the bug database, and I found you're not in it. And the guy said, yeah. He said, in the entire time you've been at this company, you have never written a bug. No. You've never had any finding from QA. No. Why? What's going on? He says, you looked at my resume. My last job, I was a satellite engineer. Right? I don't write bugs. Right. So the point is that there are a set of things that you want to look for, and those aren't what you necessarily look for. That guy, if you looked for heroics, if you looked for the person who was up late at night, he went home at 5 p.m. every single day. He came in at 9 a.m. every single day, and he took an hour lunch every single day. He was never a hero. Everyone else was crunching. He'd go home. He'd ask if he could help anybody, but his stuff was done, and then he'd go home. Right? So he never got recognized until my dad thought to look in the bug database and realized that he had been boringly successful for 4 years with no one ever noticing. And he had had more positive impact on the company as a result than any of those people who have been celebrated for staying up all night to fix a bug they created.
Excellent. Well, thank you, Arlo. Arlo, we are at the top of the hour. I don't see any more questions. We're certainly here to stay around for another 5 minutes or so, Agile in Action, and as well as Arlo and Marion. But at the same time, I want to respect people's time. So I would say that officially, Agile New England said, thanks for the story. The presentation's formally over. So we're going to conclude and give Marion and Arlo a big thanks for being here. Give Jason Applied Frameworks, thank you for sponsoring us. And again, we will give you, I'll send out an email with information after this. And Marion, do you want to close with anything else?
No, just thank you, everybody.
We want an introduction to the little guy there.
This is Dax. Dax is 7 months old and very precocious and curious.
Just like a good engineer, right?
Very much.
Okay. Well, thanks everyone for joining. Really enjoyed having you here. And again, we'll send out follow-up information as in the next couple of days.
Thank you for everyone from around the world, those who stayed up late or got up early. I appreciate it. Good to see you here.
Yeah. Thank you, Arlo.
Thank you.